Hello everyone. Today I'm going to talk about how to do the steel design in robot structural analysis. Today I have a steel frame here. It is a 2D steel frame, and I already defined the self-weight, light load, and wind load for the structure here, and this is the load combination for the ultimate strength is from number 5 to number 15, and the last combination here, the combination for serviceability. Now for today I only design for ultimate strength only, so I won't select the serviceability here. Now the first thing that we need to do is to set the bar type. So I'm going to display this member by the member type. So first I'm going to set the column type here. So I click on this button, and you can choose anything, but I'm not going to use the default value here, but you can check if it is suitable for your structure or not. So I'm going to click new. I'll name this core 1. So we need to look at the configuration that we need to do in this window. The first thing is we need to set the backlink length coefficient, and this is for the y. Y is the strong axis, and z is the weak axis. So the strong axis for this column should be full length, because there's no brace on that column. But for the z-axis or weak axis, we need to change it. I'm going to click on the customize here, because it's easy for us to define, but you can also use the default value if it's suitable. So I'm going to click on this, and the internal bracing window pop up. So this is the backlink z direction. Now you want to define where your brace are, you can click on this. I prefer to use rear, but you can use relative as long as it okay. And one more thing is you need to make sure this is the column, the number of the column that you want to set the bar type, because as you can see here, the number of beam and column is not the same. So in this case it is 1, so it's okay for this case. First I will assume that the brace start from, let's say 3 meter, and then it's the next brace will be at 4 meter. Next one is 5, 6, and 7. So this is our brace. Now you can also set the lateral backlink in this window, but I will show you. I will go to that window again. Next we look at the flexural torsional backlink. This is checked by default. It's okay for the case here. And the next here part here is the lateral backlink parameters. So first you need to set the CB. You can use CB equal to 1 following the ISC 360 16 standard, but in this case I will set the program to calculate the CB automatically. So I click on this button and I click OK. Now next, the lateral backlink length. This is for the upper flange and this is for the lower flange. What this means is that you can set the lateral backlink for the upper flange and lower flange differently or the same. It's up to you. Now I will click on this again, so this window will pop up again. So you remember the backlink following z-axis. Now I just copy on this because we use the same member for the backlink here and the lateral backlink here. And in general, this for the structure like this, the bracing member should be something like cold form, Z section or C section. It's depend on the designer. And next is the lower flange. I will copy this again and paste it into this box. So as you can see, this is the lower flange and this is the upper flange. So normally we don't brace this much because it's just waste of material. So I'm going to reuse some point here. Okay, I will only use 3 brace for the lower flange, and you can click OK. Now that's all for the column backlink. You can also set the seismic analysis parameter, but for this video I'm not going to cover this part. I'm going to save, and next we can assign this member type to our column. I will select the column here and apply, so this will become column 1. Next we set the parameter for our rafters or beams. So I will just rename this. Let's say beam 1. Now I'm going to set the backlink length coefficient for the z-axis again, but this time we change it to number 4 because we want to set it for the beam. So as you can see, the length here is changed because this is the beam, not column anymore. So in this case I will delete this first in order to see. So first I will start from length from 1 meter, and then 2, 3, 4, 5, and so on. Because I assume that my purlin is my purlin spacing is 1 meter from each other, so I will set it like this, and I copy and paste to this box and also this box. Again, for the lower flange, I will not use all the braces like this. So in this case, I will skip 2 points. I will delete this. So this is how I assume that the rafter here is going to brace. So we're going to be like this. Now I will save this and I will assign our structure. So that's all for the steel 2D steel frame here. But one more thing that I want to change is the support here. I don't want to use the fixed support like this. I'm going to set this support again. So first I will add the new support. So the moment for the moment rotating by the y direction should be released. So I mean the rotation, sorry. So I'm going to deselect this one. I will apply first. Okay, so as you can see, the y direction it can rotate through rotating by the y direction. You can use the full pin, but in this case we cannot use the full pin because this is a 2D frame. It's supposed to brace in the direction of the weak axis of the frame also, because if there's no bracing it will not be stable anymore. But for this video, in the case here, this is just a 2D frame. I only design it as a 2D frame, so I will not release the other direction. I only release the rotation by the y direction. So now I will try to design this first. First we click on the member verification. I close this first, and let's design the column first. So this is our combination. You can click on it and choose the combination that you want to design, and in this case I select all, and it will put only the ultimate strength combination. So next I can click on the calculation, but before that I want to show you the configuration also. For the default option here, you can use this option, it's okay. But if you want to change something, you can change it here. This is the calculation point, so if you want more point on the member, you can also change this. And also the efficiency ratio, if you want lower than 1, or if you are brave enough to use more than 1, it's up to you. And that the other thing is just the option that you can choose, like the calculation method. If you want to use the ASD, you can also select ASD here, but in this case I will use the default value, the default option, like in this window. So I'm going to close it, and I will click on the calculations. Sorry, we need to run the analysis again. So I will click on the calculation button here, and I will put the number of the column again and click on the calculation, and the result here is seem to be okay, but it's too safe. It's not economic. You can check on the ratio here. 0.6 is too safe, not economic at all. So we can change the section, but I want to show you the let's call the calculation notes, the brief results. So we have the member parameter. This is the parameter that we set in the member type here. So this is for the z-axis. This is the CB that the program calculated, and this is the internal force from the structural loads that you input. So it will take this for design, and this is the design strengths, and this is the result. You can check the ratio here. So this the results show okay, but if you want to check more detail, you can go to this tab and check the value that the program calculated. And one more thing, you want to put your calculation note into the report, you can click on this, and you can copy or use as theme fit. Now let's check on the beam here. So I will put number 4 and number 5, and as you can see, it's also okay, but the section is too safe, not economical again. So, and you can also check the result here. And one more thing, you can check the box here also. The critical load combination is the ULS number 5, and you can check the number 5 here, this one. And the critical location of the beam is at the x equal to 0, meaning that the length is equal to 0. It means that the critical point is at the location 0 here. So that's it for the steel design. And if you want to change the section to make it more economical, you can change it in here. Now let's say I will use 5 mm and 8, and this is, let's say, 700. Now I will change this again. Now for this time I will design all the member. I will copy and paste here. So the ratio seems to be bigger, so you can change like this until something like 0.9 or 95. It should be more economic for the so that's it, guys. For this video I only cover the steel design part here, and in the next time, if it's okay, I will cover all the part for the steel design, the full tutorial, start from modeling to the steel design, and uh, adjust as much as possible to be economical, safe for you guys. But that's it for this video, and I see you guys in my next video. Thank you.